All right, today we're doing something really cool. We're going to take a tour inside a factory that is, well, it's pretty much a robot that builds other robots. We're talking fully automated, building smart robot cleaners. This is a true marvel of modern manufacturing, so let's jump in. Okay, so this awesome hand-drawn blueprint, that's our map for this whole journey. It lays out the entire factory floor for us. We're going to follow the creation of a single robot, all the way from just a pile of raw materials to a complete, fully functioning smart machine. You ready? Let's get started. So our tour has 5 main stops. First, we'll check out the basic principles of the factory itself. Then we'll see how the robot's body gets made. After that, it's all about adding the brains and the senses. Then comes the tough part, the final gauntlet of tests. And to wrap it all up, we'll talk about what this automated revolution really means. All right, we're heading in. Now, you have to understand, this entire factory is designed around one really powerful idea, a perfectly seamless straight line flow. I mean, raw materials literally go in one end, and a fully tested, intelligent robot comes out the other. And the craziest part, there's almost zero human intervention along the way. So what's the secret sauce here? It's something called fully automated production. The best way to think about it is like the factory's circulatory system. You've got this whole network of conveyor tunnels and material pipes connecting every single machine. It's designed so the process never, ever stops. Everything is exactly where it needs to be, precisely when it's needed. Okay, now for the fun part. Let's see how this actually works. We're now entering the section where the robot gets its physical body. This is where those basic raw materials get transformed into a durable, super precisely engineered shell. And it all starts right here with the building blocks. I mean, the factory is fed this constant diet of stuff like plastic granules, little metal components, all the electronic parts, wiring, and of course, battery components. These are the fundamental ingredients for every single robot that gets made here. This is where the magic really happens. First up, these superheaters melt down the plastic granules until they're liquid. Then, boom, the former machine injects that molten material into molds, instantly shaping the robot's outer shell and all its internal structures. And right after that, a cooling system solidifies everything super fast, which prevents any warping and locks the parts into their perfect shape. It's this incredible high-tech dance of heat, pressure, and cold. Okay, once that shell is formed, it's immediately whisked away to the CNC drilling machines. Now, CNC, that just stands for Computer Numerical Control, and what it means is that every single hole for every screw, sensor, and motor is drilled with insane computer-guided accuracy. We're talking down to the micrometer. So why is this so important? Well, think about it. For a complex machine like this, perfect alignment isn't just nice to have, it's absolutely crucial. It's the foundation that makes sure everything else works. I mean, what good is a robot if its parts don't even fit together, right? So, the body is built. It's solid, it's precise. But, a body without a brain is really just an empty shell. So now it's time to give our robot its intelligence, its nervous system. In this next stage, we're going to see how all the intricate electronics and those final finishing touches actually bring this thing to life. Of course, before you can connect anything, you need, well, the connections. And check this out. These incredible wire processing machines are basically automated electricians. They cut, strip, and bundle all the different wires needed for the sensors, the motors, the battery, all at a mind-boggling speed. This is literally the robot's nervous system, and it's being crafted with flawless precision. All right, now for the finishing touches, where the robot gets its final look and feel. The shells go through 2 key steps here. First is laser texturing, which carves these really fine patterns onto the surface. This is for both looks and for grip. Then it's off to the coloring machine, which applies a perfect, uniform coat of paint for that clean, sleek finish. So you end up with a robot that looks just as smart as it actually is. One of the coolest things about this place is that it isn't just cranking out products. It's constantly learning and improving. They have this dedicated experimental room where they test new components for things like durability and resistance, long before they ever get near the main assembly line. This is how they guarantee the quality of today's robots, while also inventing the robots of tomorrow. Okay, deep breath. All the individual pieces have been forged, wired, and finished. Now we are heading into what is probably the most exciting stage, the final assembly. This is where a whole collection of carefully made parts finally becomes a single, fully functional machine. And there it is. The robot is all put together. You can see the motors are installed, the sensors are all mounted, the battery's locked in place. It looks, for all intents and purposes, like a finished product. But really, the biggest question still hangs in the air. It's built, but does it actually work? And this is where you see just how smart and flexible this whole system is. This one single assembly line can build 3 different versions of the robot on the fly. You've got the Everything Cleaner, which gets a full mop and water system. Then there's the standard Robo Vacuum, which skips the mop parts. And finally, the Robo Vacuum Lite gets a simpler battery setup. The line just knows to add or leave out certain modules depending on the order. It's basically mass production, but customized. Well, to answer that question, every single robot that comes off this line has to survive what they call the testing room gauntlet. And it is brutal. It's put through this whole series of automated checks. Can it move and navigate a complex space? Are its sensors and its LiDAR, that's the laser system it uses to map the room, are they perfectly accurate? Does the battery actually last as long as it's supposed to? Is the suction powerful enough? I'm telling you, only the ones that get a perfect score on every single test are allowed to move on. So what happens if a robot fails one of those tests? It doesn't just get tossed in a bin. Nope. The system is smart enough to automatically send it right back down the line to get corrected. It creates this perfect closed loop of quality control. The standard here is perfection, period. Nothing leaves this factory until it's flawless. Wow. So we've literally followed the journey from a tiny plastic granule all the way to a complex, intelligent machine. So let's zoom out for a second and think about the big picture here. Because this factory, it isn't really just about building robot cleaners. It's a preview. It's a genuine glimpse into the future of how we make things. When you boil it all down, the whole system really rests on 4 key pillars. First, you minimize manual labor, which in turn reduces production errors. This allows you to seriously ramp up the speed of output. And you do all of this while maintaining incredibly high-quality standards, thanks to all that automated testing. It's a simple but really powerful formula. And that, right there, is the journey we just witnessed. A complete transformation. We went from a pile of raw plastic and metal bits to a fully packaged, intelligent machine ready to go. And the whole thing was orchestrated like a symphony of automation. So that leaves us with one last, pretty big thought to chew on. Sure, this factory builds robot cleaners, but these same principles, they could be used to build almost anything. So when a factory can build smart, complex products with this kind of efficiency and perfection, what's next? What does that mean for the future of the things we create? And more importantly, how we create them?